Hey there, algebra students. Happy Labor Day here at Walton High School on Halloween. That's right, all of our math teachers dressed as different holidays, and mine was Labor Day. So I'm walking through the day with a little bit of a little act going on. Anyways, here we go. I wanted to create this video because I wanted to help y'all just reinforce how to graph these exponential functions. I think it's super important to feel more and more confident with graphing these going into the test and going into next week and later on this week, whenever you guys watch this video. Okay, so we've got an exponential function there. A lot going on here. Couple things that I want you guys to do when you first look at one of these, just to tip you guys off for some more information, is realize this is a positive value out front. And if we have a positive value there, that means we're going to be above wherever our asymptote is. Also, simultaneously, we can look at that value and identify that our asymptote has the equation y equals 1, right? It's a horizontal asymptote, so we know that at the height of 1, we've got a horizontal asymptote that our function is going to approach in one of the two directions but not reach, okay? And then it's either going to kind of decay into that and grow away from it in the other direction, or vice versa. Okay, so these are two things I would instantly look at when identifying what to do first for these problems. So first off, because it's positive, we know it's going to be above this asymptote. All right, second off, we're going to look next at what type of value our base is. Since our base is a fraction here, and it's above the asymptote, and this fraction specifically is less than 1, now we know, okay, we're going to have a decay function. So it's going to model this type of shape. So at the end of our function, at the end of this problem, we should have a graph that models this shape. Right, so I just want to kind of key in on that. So first thing we're going to do, a lot of times they're going to ask us to find the y-intercept. Now the y-intercept is specifically the coordinate when we plug x in for 0. So that always works out, right? So for example, if I was choosing to make an xy chart, we have to create this x equals 0 point because they ask us for the y-intercept most often. Okay, so I'm going to go ahead and show my work over here, but basically I'm taking all of this expression and I'm going to be substituting in 0 just for x, right? Here's another key right now. Whenever I raise a base to the power of 0, any base, it could be 1/2, 3, 20, anything to the power of 0 is going to be 1. That makes this a much simpler problem because 1/2 to the power of 0 is going to be a result of 1. Now I still have this 3 times that 1 and this other plus 1 tacked off on the side. So again, just doing my order of operations, 3 times 1 is 3, plus 1 becomes 4. So that is my y value of my y-intercept. So at least I've got the point 0, 4. And I'm going to go ahead and plot that. 1, 2, 3, 4. Right up there. Oops. 1, 2, 3, 4. So at least I've got one of my points plotted. Next, I'm just going to go ahead and pick the next easiest x value to work with. The next easiest x value to work with is the x value of 1. So again, I'm taking this expression, okay, and I'm going to rewrite it with the x value of 1 substituted in. Now, if you're wondering, well, how did I pick that point? You know what? I just not randomly, I kind of looked at this and I said, okay, what's an easy exponent to always use? The power of 1 is always an easy exponent to use, all right? So specifically, in this case, raising it to the first power, doable. That creates just 1/2 as my fraction. Now, 3 times 1/2 is where we started getting a little bit more difficult maybe for some of you algebra students, but that's okay. We're going to practice our fractions more and more. 3 times 1/2 is 3/2. 3/2 plus 1. I'm going to actually turn everything now into a mixed number. 3/2 is 1.5 plus another 1 is 2.5. And I know we said most of this year, let's not work with mixed numbers, but graphing is the one time where mixed numbers really does make sense. Okay? So I've got 2.5 is the next point. So 1, 2.5, right over there. Okay? And I'm going to go for one more point, but in this case, if you notice, because I've got a decay function, the further and further I go in this direction of x, the more I'm raising a fraction to a power. Whereas if I go in the other direction, like a -1, hold on, let me pause this for a second. Whereas if I go in the other direction, by going in the negative direction for x, I'm actually going to turn this fraction into a whole number. Watch. Just substituting it in, I've got 3 times 1/2 now to the negative power of 1. Okay? Anytime we have a negative power of 1, I want y'all to recall from last unit, that flips our fraction and gives us the reciprocal value. So instead of 1/2 raised to the negative first, 1/2 raised to the negative first becomes 2/1 now raised to the power of 1. So just 2/1, right? And keep in mind, 2/1 is really just 2. So I've got 3 times 2, then adding 1. 3 times 2 is 6 plus 1 gives me a power of 7. So I can plot those points, -1, comma 7. And now if you go back and connect these into a decay function curve, you'll have our graph fully mapped out. Now, here's the deal, guys. At this time, if you pause this video and rewind it all the way to the beginning, you'll see that my shape of my function actually matches what I wanted and intended for it to be. I'm going to go on to the next question now. Okay? Also, actually, just to kind of recap, from here, we could actually go through all of the different skills that I could look at. Okay? I could identify what my domain is. My domain for all of these functions goes from -infinity to infinity, meaning it goes everywhere left and right. I could find out what my range is. Okay, well this is a function where my entire graph is above my asymptote, meaning the asymptote is the absolute lowest the function is bounded by. It doesn't even actually get there. It's not a value in our range, but everything is from the asymptote and above. So we look at from the asymptote's height of 1 and above all the way up to infinity. Okay, so this gives us domain and range. Also, this problem is always decreasing. Remember, true decay functions that are above the asymptote that decay into the asymptote are going to be decreasing functions. All right, what else can we look at for this function? What else might we be asked? Well, we could be asked what the end behavior is. Okay? And recall, end behavior asks us as we go to the left, and the way we write that is x goes to -infinity. That means as we go to the left, y goes to whatever height it goes to. Well, as we look to the left, the y keeps going up forever to infinity. And as we go to the right, as we look to the right, hey, our height is approaching that asymptote of 1. Okay, I wanted to go through the next example, all right? Once again, the first thing that I want to identify when I'm looking at these functions is our first multiplying value out front, our a value, and I'm going to notice that that's negative. So because this value is negative, we know that wherever our asymptote is, so wherever it is, if it's up there, that's fine. If it's down here, or wherever it is, we know that our function will be graphed below that asymptote, okay? So that's kind of the first thing I'm looking at, is it's going to be graphed below that asymptote, all right? Next thing I'm going to do is I'm going to actually identify where is the asymptote. And since we've got a +0 at the end of this, I know that, and I know we don't have +0 written, but for all intents and purposes, we can assume it's there. Since we have a +0 up there, we know that our asymptote is, in fact, at the height of 0. So y equals 0 is that horizontal asymptote equation, okay? But again, my main goal for class today right now is I want to help us understand better how to come up with those values and those points that are the exact points on our graph, okay? So specifically, they usually ask for us to find the y-intercept. Y-intercept, once again, is when x is 0. So if x is 0, right, that's what we're going to look for first. So I'm just going to go ahead and plug in 0 for x. Now in this case, got to deal with the bells here. In this case, our exponent is not just x. Our exponent is x plus 1. It's a little different from the last problem, meaning our exponent isn't just, hey, whatever I plug in for x goes up there. No, whatever I plug in for x goes just in place of x. But my exponent is all of that 0 plus 1. So in reality, I've got negative 1/2 times 2 to the first power, because that's what 0 plus 1 is, which really becomes negative 1/2 times 2. Okay? Negative 1/2 times 2 is negative 1. So we've got that coordinate right there, 0, comma, negative 1. Nice thing is it's below the asymptote. So that's what we expected it to be. Okay? Next thing I want to look at, all right, is another x value. So what's a pretty easy x value to work with also? The x value of 1. Why is it an easy x value to work with? Okay, because the x value of 1, when I plug it into my function, gives us a very simple exponent as well. Right? If I plug in, right, originally I had x plus 1. If I use x as 1.
Maybe to the attendance office, please. Braxton, maybe to attendance. Thank you.
If I have x is 1, and I substitute that in there, I get 1 plus 1 for my exponent. And the reason that's a simple exponent is because we should know how to take 2 and square it, right? That's what's happening. 1 plus 1 is 2, so we're taking 2 and raising it to a power of 2. Very doable. So we have negative 1/2 times 2 squared is 4. Negative 1/2 times 4 is negative 2. So I've got the point 1 comma negative 2. All right? Now, I'm going to do something a little bit differently in this next example, okay? For this next example, well, let's keep going actually, that's fine. We'll pick the x value of 2. I'll do this one a little bit quicker. Negative 1/2 times 2 to the 2 plus 1 power. So negative 1, how did I get 2 plus 1? Substituted 2 in right there for x, okay? Negative 1 times 2 to the third. Negative 1 times 8 is negative 4. Boom, 2 comma negative 4. We should already start to see the shape of this exponential. And just for good measure, I'm going to do one more, but I'm going to do this point in the other direction. Right? If so far what I have looks like this, I'm expecting this other direction to be somewhere right there, like a fraction. Okay? Let's see if that actually works out. I've got negative 1/2 times 2 raised to, this is a very interesting power. I've got negative 1 for x. That's actually a really good x value to choose, because when I take negative 1 for x and add positive 1, I end up with the exponent of 0. So that was actually a really great point to use, because an exponent of 0 just makes this 2 to the 0 regular 1. So I had negative 1/2 times 2 to the 0. It's really negative 1/2 times 1, which is negative 1/2. And guess what? That is the fraction that I was expecting it to be, just like I showed you in that last picture. And so my graph follows this exact shape, which makes sense, because watch this. What if that negative had not been there? Then this would have been a true growth problem, which would have looked like this. You guys with me on that? Meaning, if this negative weren't there, it would have looked like that. Well, what does a negative do? When I have the negative there, it is called a reflection. So it makes sense that our actual function is a reflection down of that, okay? And that's kind of what we have there for that problem. All right, going on to the next one, and final one I really want to go over in detail today would be this example. So once again, I'm going to look at this problem. I'm going to say, what type of value is that? It's a positive value. Therefore, it's above my asymptote, okay? Where is my asymptote? Ah, this minus 4. That is the height of my asymptote. The asymptote is a horizontal line, which has an equation of y equals -4. I'm just going to draw a horizontal line as best as I can, and I'm just going to grab it and move it to the height of -4. Okay? So now I've got my asymptote graphed. Because it's going to be above it, I look at this type of number, I say, oh, that's going to be a growth problem. So just remember at the end of this problem, it should look somewhat like this. It should be a growth problem. So let's hope that we get that. And now let's just choose some x and y values for this to be. Okay. So going through this, choosing some x and y values. I don't know, just randomly off the top of my head, I'm going to choose -1. I love -1 here because that once again gives us an exponent of 0. Because plugging in -1 plus 1, exponent of 0. We like that. We can work with that. I'm going to also plug in 0, and I'm going to also do 1. Okay? Just erase that. That was tailing off a little bit. Woo, not bad. Height of 4. There we go. Okay. So plug in, and why do I choose these? These are the easiest x values to work with, because you'll see that they give you different exponents. 2 times 3 to the -1 plus 1 minus 4. 2 times 3 to the 0th minus 4 becomes 2 times 1 minus 4. 2 minus 4 is -2. Okay? 2 to the 2 times 3 to the 0th, that's 2 times 1. 2 times 1 is 2, minus 4 is -2. Boom, got that point. Now let's go to the next point. If x was 0, my exponent would be 1, which means this would be 2 times regular 3, which would be 6 minus 4, which would be +2. So I'll do that again. 2 times 3 to the x is now 0 plus 1. We have a plus 1 up there. 2 times 3 to the first minus 4. 2 times 3 minus 4. 2 times 3 is 6. Minus 4 is 2. Final one, I'm going to change this. I'm going to plug in an x value of 1. So now I've got the exponent 1 plus 1. Exponent of 1 plus 1 is 2. 3 squared is really 9. 2 times 9 is 18. 18 minus 4 is 14. Okay, and now I'm going to graph that. -1, -2, 0, 2, 1, comma, 14, way up high. You know what, let me clean that up just a little bit since this is going to get published. Ooh, cleaned that up a lot. That looks real good. Not bad. Okay. That is just a quick little review on how to graph, how to find points, how to find y-intercepts specifically, and I did a little bit of extra stuff along the way to hopefully assist you. Hopefully that sets you up nicely for this next unit.